In this video, we will explore some of the world's most dangerous chemicals. Here we have assembled the ultimate chemical death squad. In sufficient quantities, exposure to any of these deadly chemicals will cause you to scramble for a piece of paper and rapidly jot down your bucket list. Number 1 on our list is thioacetone. You don't have to worry about it exploding, catching fire, or even maybe causing cancer. Thioacetone is a little cute puppy compared to the other compounds on this list. Now, imagine that little puppy emitting the most repulsive odor imaginable. Yes, thioacetone is officially the smelliest chemical on the planet. In this case, the carbon atom is covalently bound to a sulfur hydrogen pair, making the chemical a thiol. In a word, it's disgusting. Both types of thiols in a skunk's spray cause severe irritation to the eyes. Rotting meat is the primary source of sulfur-containing compounds. Therefore, developing an acute sense of smell that can distinguish between sulfur and other odors is important. You know, so we don't actually eat rotten meat. But if you're looking for the most offensive odor ever, go no further than thioacetone. Just one drop of this stuff will be instantaneously detectable from half a kilometer away. Here are interesting stories about thioacetone. One day in the 60s, a small vial of this substance was accidentally knocked off of a shelf in a laboratory. People were chucking their food in buildings 200 meters away. In 1889, chemists at a soap factory in the German city of Freiburg were said to be working on a bigger molecule known as trithioacetone, which is used as a flavoring and a fragrance. This incident is the finest illustration of thioacetone's silent but deadly potency. Nonetheless, when it was separated into thioacetone, employees began becoming sick. People in the neighboring areas started vomiting for no apparent reason. Because of this, the entire city had to be evacuated. Scientists aren't exactly racing to investigate thioacetone and thiols in general, although there may be a lot to learn about them. Next on our list is chlorine trifluoride. Let's travel back in time to Germany in the year 1939. In a hidden bunker on the border between Germany and Poland, Nazi agents monitored the production of a newly discovered substance they called Substance N. It detonated in water, boiled in air, was lethal if inhaled, and emitted toxic hydrofluoric acid as it deteriorated. When ignited in a flamethrower, it may reach temperatures of about 2400 degrees Celsius. Even the German troops, after doing some investigation on the topic, said, "Whoa." The Nazis decided Substance N was too dangerous to continue testing, so they stopped. The plan was to provide the troops with Substance N to turn Allied bunkers into a bowl of hot porridge. You may get an idea of the magnitude of the problem merely by reading about these compounds, which rank among the deadliest in the world. To clarify, I am referring to poisons so potent that even the Nazis thought that they were insane, compounds that explode when touched, and things that may even disable you owing to their total, debilitatingly horrible stink. Let's start with the Germans' underground weapon storage facility and what they had in it. As opposed to the 90 tons each month they had planned for, they only produced 30 tons total during the length of the conflict. Chlorine trifluoride is the most powerful fluorinating agent ever created by humans. Chemicals that contain fluorine are known as fluorinating agents because they exchange hydrogen atoms and other molecules with fluorine. Fires caused by fluorine are much riskier to work with than gas itself because of the exothermic reaction they involve, which, as any chemist will tell you, is not something you get to say very often. When it comes to oxidizing substances, fluorine outperforms oxygen. Oxidizers are compounds used in combustion because of their capacity to remove electrons from other molecules during a chemical reaction. In this sense, chlorine trifluoride may be so effective that it can light things on fire that most people wouldn't even think could burn, such as bricks, asbestos, or things that have previously been burned. When US scientists first tried to ship chlorine trifluoride in bulk in the early 1950s, the steel tank cracked and a full ton of it spilled out, burning so hot that the chemical ate through an entire concrete floor and then a meter of dirt and gravel beneath that. Since then, the use of chlorine trifluoride as a rocket propellant has been abandoned. One eyewitness describes the leak simply as, "The concrete was on fire." Chlorine trifluoride is still made by semiconductor companies to be used in the cleaning and sterilization of their machinery. It may be safely kept in an ordinary steel drum if it is airtight and great care is taken. However, it quickly scorches the internal lining of the container, leaving behind a non-reactive layer of metallic fluoride. I don't know about you, but that doesn't sound as reassuring as it should be. Third on our list is everyone's favorite acid, Fluoroantimonic Acid. Because no compilation of toxic substances would be complete without a mention of superacids, obviously. An acid is a molecule that can donate a proton to a nearby base. For the record, a proton is all that's left of a hydrogen atom once all of its electrons have been stripped away. This process is known as protonation. The strength of an acid is proportional to its propensity to give up its proton. Acetic acid, the undiluted form of vinegar, is a relatively weak acid, and it takes quite some time to protonate the other molecules. Most of it will be completely pointless. A proton is like a beach volleyball during the summer. Nevertheless, a proton will be punched in the air by an acid such as sulfuric. Remember that fluorine, as stated in substance N, is completely insane. Fluoroantimonic acid is 10 quadrillion times more potent than sulfuric acid. All this molecule wants is a good excuse to disassemble. Without hydrogen to attract electrons, the remaining fluorine and other element, antimony, do so, leaving nothing but biological muck. When the acid dissolves the fatty organic tissues of your skin and muscles, the fluorine will burn through your bones, which is quite exciting since fluorine loves to link with calcium. Only store fluoroantimonic acid in containers made of Teflon that are hermetically sealed against air and moisture. It's important to remember that the carbon-fluorine bonds that bind Teflon together are the strongest bonds available in organic chemistry. It is difficult to do experiments with this acid, therefore, there is still much we don't know about it. It is too big to fit in a syringe or a microscope slide, it treats glass like it's made of cotton candy, and if you tried putting it in a fume hood, the hood would be burned up. All you can do is stare at it, as far away as possible preferably. Our next chemical on the list is going to be an explosive one, Azidoazide. The most potent explosive compound ever created, its chemical family, high nitrogen, energetic materials, characterizes its nervous behaviors. In addition, all nitrogen wants is some room to spread out in. Two nitrogen atoms joined together form one of the most stable molecules. Their triple electron bond is so robust that it is typically only broken in nature by a direct hit from lightning. When two nitrogen atoms meet, they release a tremendous energy level due to their bond strength. To that end, each AA molecule contains, because some people may have trouble pronouncing Azidoazide, we've shortened the term to AA. Evidently, that's where the string is. None of the molecule's 14 nitrogen atoms are triple bonded due to its unusual chemical structure. To the contrary, they are in an inherently unstable, high-energy state and would want nothing better than to transition to a low-energy state. That's why AA is so quick to react and so powerful when detonated. If you're curious about the level of fragility of this stuff, inaccurate measurements of the phenomenon's sensitivity make it challenging to draw firm conclusions. It was created in 2010 by a team of German scientists in order to discover more potent compounds with the help of the US military. They also noted, the sensitivity of C2N14 is beyond our capabilities of measurement. Even the smallest possible loadings in shock and friction tests led to explosive decomposition. In their original report on the discovery, indication of AA's potential for explosion include the following: moving it, shaking it, putting it in a solution, leaving it alone on a glass plate, putting it in a spectrometer, and turning it on, or my personal favorite, doing nothing with it. Just leaving it alone has the potential to make it explode. A team of scientists was dealing with this chemical after having it stored in a temperature and light-controlled chamber with a shock-proof explosive case. It detonated. It was regarded as a very exciting discovery by the team's principal scientists, but I also came across some criticism of it. If I was a scientist working with Azidoazide every morning, I would consider it a miracle just to see my hands completely functional. And last on our list is Dimethylcadmium. In this example, the metal is cadmium, which is very unpleasant on its own, but this complex is an organometallic compound, meaning its carbon atoms are connected to other metal atoms. Yes, Dimethylcadmium causes explosions and causes an uncontrollable fire to spread, but that is not what makes it so deadly. Probably, gram for gram, it's the most poisonous chemical ever created. It can cause both short-term and long-term problems. This signifies that it is fatal right now and in the future. An early innovator in metal organic chemistry originally synthesized it, a guy from Germany named Erich Krauss. It was 1917. Now, Krauss, to give you an idea of his style, was 37 when he died in his lab from chlorine poisoning, but not before he announced the discovery of dimethyl cadmium. When inhaled, it is quickly taken into circulation, where it acts as a chemical driver for cadmium's harmful effects as they move through the body. Effectively exploiting your circulation, it soon affects organs like your lungs, kidneys, and liver, where it can pull electrons off of atomic nuclei. Don't get your hopes up if you make it through the first few hours after being exposed to dimethyl cadmium. Further, it's highly carcinogenic, meaning it will give you cancer as a personal revenge. Due to its potency, it is illegal to exceed even a concentration of a few millionths of a gram per cubic meter of air when it's in the form of a vapor. Let's say you one day bumped into a shelf in a lab and dimethyl cadmium spilled. How do you plan on getting rid of the spill? Do you clean it with water? Wrong answer. The reaction with water results in a great deal of heat and a great deal of hydrogen gas, which is combustible. Therefore, it does really detonate when submerged in water. Yeah, you heard that right. It'll explode. Perhaps we could try sweeping it. Well, the friction will cause it to explode. Maybe you could just let it rot away on its own? It serves the purpose, but it'll leave a crust of dimethyl cadmium peroxide, an explosive sensitive to friction. Yeah, another cause for an explosion. Oh, and to top it all off, this chemical has an awful, unpleasant, metallic, and repulsive stench. So, it's really best to just steer clear of it. And those are 5 deadly chemicals you've never heard of. If you liked this video, be sure to subscribe for more interesting facts.